Hello everybody, welcome to our next unit. In this unit we are going to be talking specifically about parallel lines and all the magic that they bring to geometry. They bring so much magic. Okay, so it's not the first time we've talked about parallel lines. We talked about parallel lines earlier this year. We wrote equations for them and stuff like that, and I know you talked about parallel lines in middle school. So the first thing I want you to do is take a pause and answer that first question. How do we define parallel lines in mathematics? All right, a lot of the answers that I get are things like lines that don't cross. And that's true. They are lines that don't cross. I agree. The people who remember what we talked about this year, or maybe in 8th grade, depending on who you had, say things like, oh, they have the same slope, or they're slanted the same. Also true. Okay, so we need to talk a little bit about what that means in geometry. Having the same slope is a very algebra definition, and we love that definition. It's amazing. Not crossing is a nice visual definition of parallel lines, but we have to be a little more specific when we talk about not crossing. Okay, so the next thing I want you to do is take a look at this second question. There's 3 pictures there, real life pictures. We've got some railroad tracks. We've got some roads, Atlantic Avenue, Main Street. I don't know what that one is over there. Something else, Main Street, North or South Main Street maybe. Okay, and then the last one we have these street signs. We have Driftwood Drive and we have Oak Street like this. Okay, take a pause. Let me know which ones of those, if any, or all, whatever, you think are parallel. Okay, so based on our definition of they don't cross, I think we probably all agree that A is parallel, right? Those 2 railroad tracks are kind of like the thing that teachers use when they talk about parallel lines. We always say they're like railroad tracks. They stay the same distance apart. We love to talk about railroad tracks when we talk about parallel lines. Okay, so A, yes, parallel. They're never going to cross. If those railroad tracks got any closer together at any point or any further apart at any point, we'd have a derailed train, and that would be bad news, right? So we know for a fact that parallel lines are parallel. Railroad tracks are parallel. Obviously, we know parallel lines are parallel. We know railroad tracks are parallel. Okay. In B, I think we might all agree that those roads come together, right? Atlantic Avenue and Main Street at some point are pretty far apart, and then they slowly get closer together, and then right around there they cross. So those are not going to be parallel. By our definition of they never cross, they're not parallel. And by our definition of same slope, you can clearly see they're slanted differently, right? If I put an XY axis here, if I put a grid on here, you can see this one has a steeper slope than that one, right? So those are not parallel. No way. The zinger here, though, is C. Is this. And see, algebra didn't talk about this. So by our definition of do they cross? Do they? It's like one's like this, but then the other one is coming out and it's like above it. I'm really bad at drawing in 3D. Do they cross? Do those things touch at any point? Even if those street signs went on and on and on forever, do they touch? I mean, they make a crisscross, but one's below the other one. They're going like this. They're kind of passing each other, but it's almost like a road that has a bridge going over it, right? They might not ever touch, but are they parallel? Do they have the same slope? One could argue they both have a slope of 0 because they're both flat. Right? And there's a question around C. This is where geometry comes in. Okay, so this situation here, the street signs, this is the one we're going to talk about a little bit more today. I think you're pretty good at noticing when things are parallel. But then there's situations like this that algebra didn't cover. And the reason algebra didn't cover it is because algebra pretty much works in 2 dimensions, right? On a flat sheet of paper. Geometry extends out into the three-dimensional world, right? So in geometry, it's possible to have a line going this way and then a line coming this way. And in algebra, that never would have happened, okay, in the algebra line stuff. All right, so let's take a look at some examples. Okay, hopefully you printed this or you have it in front of you so that you can type onto it or however you want to handle it. I wanted to make sure that you have these diagrams. If you don't have these diagrams, take a pause and draw them so that you have something to mark up, because you're going to have something to look at and mark up as we go through this. All right, so here we go, our first definition, parallel lines, right? Notice here, this line AB and this line CD, they look parallel, they look like they're never going to cross. But they also have a notation on them that's important, okay? In geometry, we don't ever want to assume anything. Like, we don't ever want to look at an angle and go, that looks like a right angle. Or, those lines look parallel. We need to know that that's a right angle. We need to know that they're parallel. The way geometry lets us know two lines are parallel is with these little symbols right here. You see those little arrows? When they put those little arrows on two lines, as long as they have the same symbol, then we know they're parallel. So these two lines, because they each have one little arrow, are parallel. Now in a different diagram, if there was another set of parallel lines, they might mark them with two arrows each. It's sort of like how they use those tick marks in diagrams to show, hey, this piece and this piece are congruent. And then if there's another set, then they use like double tick marks or triple tick marks. Same thing with these. Okay, so let's write a few things down. Parallel lines. Very important definition here. Lines that do not intersect is the old definition that we've been using, right? This, now that we're big kids, is the big word, coplanar. Coplanar lines that do not intersect. Now, if you remember the definition of this word from back when we talked about points and lines and planes, way at the beginning of the year, remember what coplanar means. It means on the same plane, right? In other words, I should be able to take my arm and go like this through those two lines and have it contain both of those lines. In other words, I should be able to draw both of those lines the way they are on some sheet of paper, regardless of if my sheet of paper is laid flat or if it's up on its side or if it's at an angle. I should be able to contain both of my lines in one sheet of paper. Okay, that's what coplanar means. Pretty much every single set of lines we've seen to this point, parallel or not, have been coplanar because we're used to working in two dimensions. We're used to working on a sheet of paper. And this is where geometry gets interesting. Okay, so we want to make sure they're coplanar. So when you write that down, it's important, please make sure you put like a star next to it or something, because that's probably one of the more important definitions of parallel lines. We know they don't cross, but being coplanar is really important. Okay, this next sentence, we use arrows to indicate lines are parallel. So like we talked about in the diagram, that right there, those two things right there, that's how we let you know that they're parallel in a diagram. So if they mark that in a diagram, they don't need to say these lines are parallel. It's marked in the diagram. It's your job to notice those little triangles and know what that means. It means they're parallel. Okay, now, sometimes they don't put it in the diagram, right? Sometimes they say it, they write it out for you. Okay, now, it would be nice, so nice, if they said, line AB is parallel to line CD, like in words, and we would say, yes, I know what that means. But mathematicians are lazy and notoriously bad spellers. So they have symbols for a lot of stuff, right? They're not probably going to write this line is parallel to this line. They have a symbol that means is parallel to, right? And the symbol looks like a little teeny tiny pair of parallel lines. So see how this is written? Line AB and line CD, and in between is this symbol that looks like a teeny tiny pair of parallel lines. So this is red. Line AB is parallel to line CD. So we replace the words is parallel to with this symbol. It is important to note that it does not matter which way you slant your lines. I could also have written here AB parallel to CD. Doesn't matter which way you slant your lines, as long as you draw kind of like a mini version of two parallel lines. All right, so that's parallel lines. We know they're in the same plane, and we know they don't cross. Okay, same plane, don't cross, same slope. All right, parallel planes, we don't really talk about slope with parallel planes, right? But parallel planes are along the same lines. They are just planes that don't intersect. Okay, so when you're thinking about parallel planes, remember, planes are infinitely big, so they're kind of hard to think about. But a plane is a two-dimensional space. So in the room you're sitting in right now, unless you're in some sort of fun house, the plane of your floor is most likely parallel to the plane of your ceiling, right? Floor's here, ceiling's here. They don't touch. It's not like on one side of the room the ceiling is really tall and on the other side of the room the ceiling is really small. Unless you live in a really fancy house with like curvy ceilings, right? If you live in a house with kind of standard ceilings, the way my house is, the floor is flat, the ceiling's flat, right? Certainly the walls that are opposite to each other are parallel. So where I'm sitting, there's a wall on my right, there's a wall on my left. Those two are parallel. They don't get any closer together or further apart, right? My walls aren't leaning in or leaning out. They're not like I said, unless you're in some sort of fun house. Okay, now, what's not parallel are two walls that come together. In other words, two walls that come together to make a corner. So from where I'm sitting, the wall that's right next to me, and then the wall that's in front of me, or even what you can see, the wall that's next to me and the wall that's behind me. They're coming together in that corner, right there. They're coming together in that corner. That's an intersection, right? When planes come together, boop, it makes like a whole big long line, and that's an intersection. So those planes back there, this wall and this wall, they're not parallel. Okay, so we need planes that don't intersect. If planes are parallel, we do the same darn thing that we did with lines. We use the little parallel signs. Now remember, we name planes one of two ways. You name a line with 2 points, right? You have to name a plane with at least 3 points, or you get lucky and they give it a name. Notice these have names, and they always give them capital letter, fancy scripty letter names. So this is plane J and this is plane K. If they had put 3 points, whoops, no. If they had put 3 points on these, we could have named them like plane ABC and plane XYZ. But they were nice. They gave the planes names, so we don't have to do that. And again, here, it doesn't matter which way you slant your lines. Those are my fancy J and K. You like them? You barely look like J's and K's. Good job, me. Okay, so listen. This last one, skew. It's a fun word to say. This is where the geometry comes in. Okay, because skew lines also don't intersect. They're not going to cross, but they're not parallel. And here's the difference. They are not coplanar. They are not in the same plane. Okay? So the reason that they don't intersect is different than the reason that parallel lines don't intersect. Parallel lines are in the same plane. In other words, if I had 2 parallel lines on the wall behind me that were just going straight up and down, they're on the wall behind me, they're in the same plane, they don't cross, right? That's parallel. Skew lines, though, don't intersect for a completely different reason. I could have a vertical line on the wall behind me, and I could have a vertical line on the wall next to me. They're not going to cross. But it's not because they're both vertical. I could slant this one over here and still have this one back behind me. They're still not going to cross because this one's operating over here on this wall, and this one's operating over here on this wall. They're not even in the same plane. I don't care how they're slanted. They're not going to cross. But they're not parallel. So geometry brings this new term to us to describe lines that don't cross, but it's not because they have the same slope. It's because they're not even on the same piece of paper. I got a line over here and I got a line over there. They're never crossing. There's no chance. They're not even on the same page, right? Think about those street signs. One was down here and one was up here. Are they crossing? No. Is it because they're parallel? No. I could take this one and turn it. I could take this one and turn it. They're not going to cross. Again, think about roads with like a road that goes over top, bridges and stuff, right? When I come to work, I come over the Liberty Bridge, right? When I come to work, it's been like a year since I came to work at the date of this recording. Not quite a year. The Liberty Bridge goes this way. There's a big fat river underneath. The river and the bridge are not parallel, but they certainly don't cross. If they cross, I'm in trouble, right? Because my car is in the river. Those are skew. Okay, so take a look at this diagram to the left. Okay, let's find some segments that are skew. I'm going to get out my highlighter. All right, so let's highlight this segment right here, PQ. All right, so I need to find a segment that is skew. Whoops, to segment PQ. All right, so in other words, I need a line or a segment that's not going to cross PQ, but for the specific reason that it's not even in the same piece of paper with PQ. Okay, the first thing I'm going to do is I'm going to eliminate all the lines that actually do touch PQ. So for example, SP touches PQ right there. He's out. RQ touches it right here at Q. UQ comes down and touches it. He's out. TP comes down and touches it. He's out. Right? All four of those segments actually touch PQ. They intersect with PQ. So that takes this part of the definition gonzo. Okay, now, what about the coplanar thing? Okay, so for example, I could say, if I can find my pen, there it is. Okay, this segment right here, SR, they're never going to touch, right? They're not going to touch. The reason they're not going to touch is because they are parallel. Right? If you think of this as a room, right? PQ, QR, SR, and SP make up the floor, right? This is the floor that's running along one side of the room. This is the floor that's running along the other side of the room. These two are coplanar. They're both in the plane of the floor. Okay? So this isn't going to be skew. Same thing with TU. PQ is running along the floor. TU is right above it, running along the ceiling, but on the same wall. That's parallel. That's not skew. What you're looking for when you're looking for a skew line is something like VR. See this line? So PQ is on one side of the room along the floor. It's over here. VR is in the opposite corner of the room going up and down. They're never going to cross. They're not going to cross, but they certainly aren't parallel. So I could say that PQ and V are. What's going on there? Oh, there it is. I could also use PQ and I'm sorry, I'm just clicking. I don't even know what I'm doing. Let me erase some of my drawings here. So you can see what I animated in here. Might be easier for you to see when it's not my chicken scratch. Okay, so another example of skew. TU, If we're thinking of this as a room, again, this is a line that's running along the ceiling on, let's say, the front wall of the room. And then look here, WS. It's on the opposite side of the room and it's running from the ceiling to the floor. So I've got a line like this, and then I've got a line way over here that's going up and down, right? We're talking street signs here, right? One's over here, one's over here, going the other way. They're never going to cross, but they're not in the same plane. They're not in the same plane. One's in a plane that goes up and down, one's in a plane that goes this way. That's skew line. So we could say TU and WS. That would be another example of skew. TU, WS. Okay, let's think if I can find, let's find another pair here. All right, let's find one more pair. Could I find something that's skew to UV? I like to just pick one and then go from there. UV. Okay, so UV. So the UV is over here on this right wall, right? So the first thing I'm going to do to find a skew line is get off of this right wall and go to the opposite wall. I'm going to go to the left wall, right? And I don't want a line that's running parallel. I want a line that's going the other way. So TP would work. That would be skew to UV. WS would also work. It would be skew to UV. Again, UV is going this way. It's on the right-hand wall going back and forth. These two are on the left-hand wall going up and down. That's skew. I'm going to use TP just because I'm a child and TP stands for toilet paper, so it makes me giggle in my soul. Sorry. Okay, so again, these are the three big definitions here. We kind of already knew parallel lines. Parallel planes is a little new from geometry. This skew here, this is the brand new business. And again, the big deal is here. They're not going to touch, but the reason they don't touch is a completely different reason than the reason parallel lines don't touch. Okay, so let's take a look at another example. I'm going to move my fat head down here for a minute. I need to look at this diagram. Okay, so in number 1 here, it says name all segments parallel to AE. So the first thing I'm going to do is go find AE. Let me find a sucker. Highlight it. Let's use this pretty blue today. Okay, AE. Ooh. Okay, there's AE. I need segments parallel to. So parallel, same plane, so they aren't going to cross. So by the same plane, again, if we're thinking this as like a room, let's stay on the same wall. So there's this kind of left-hand wall here. The piece that would be parallel to AE on this left-hand wall would be this one right here, HD. So that's one, HD. Okay. We have, if I can erase my chicken scratch so that you can see a little better. We have this front kind of wall of the room. On this wall, AE is the left corner, your right-hand corner. Where's my pen? Oh, there it is. Okay. Your right-hand corner is right here. FB. These are parallel. So FB is another one. In fact, any of the corners of the room are going to be parallel to AE. So I could also include GC in this. Now GC is one that you maybe don't see as easily because we don't actually see anything connecting AE and GC. But if you think about it, I could, if I slice that room like this, slice it in half, there could be a plane that goes through the middle of the room like that. I know some people are better at picturing than others. I have to tell you, I am the worst picturer in the history of picturing. I'm very, very bad at that. Okay. So we've got 3 lines. Again, AE is a corner, so parallel to it, parallel, are going to be HD in this plane, FB in this front plane, and then GC is a kind of diagonal plane that goes through the room. Okay, parallel planes. Okay, the first thing we need to do if we want to identify some parallel planes is identify one and then see if we can find one parallel to it. Okay, so let's go with, I'm gonna, again, let's talk about this plane right here on the side. Again, if we're thinking this is a room, it's like the left-hand wall of the room. Okay, parallel to the left-hand wall would be the right-hand wall. My computer's taking its time today, huh? Okay, so parallel to the right-hand wall would be the left-hand wall. So I can say that those are a pair of parallel planes. So I'm going to name these planes with at least 3 points. So I'm going to say plane, I don't know, ADH. You could name it ADE. You could name it EHD. It doesn't matter as long as you use 3 points. And on the other side, I'm going to say plane, I don't know, FGC. Any 3 points will do. You could name it plane FGB, FBC, FBG, whatever. Just use 3 points. The word plane and 3 points. All right. Now there's a pair of parallel planes. Now it says 2 examples. We have more than 2 examples here. We'll go through all of them. Why not? You don't have anywhere to be, do you? Okay. What about if I looked at the floor of this room? The floor of this room, what would it be parallel to? The floor of the room, hopefully, again, unless we're in a fun house, is going to be parallel to the ceiling of the room. So let's name those planes. Plane, the floor, maybe I'll call it ABC, just because I'm going to be alphabetical. ABC, leave out the D. Again, you could call it DAB or CAB. Some people really love making sure their letters spell something when it's possible. Go for it. Okay. Now I need the plane of the ceiling, right? So I'm going to call it plane HFG. 3 letters, any 3 letters will do. Okay, so that's floor and ceiling. So we did left wall, right wall. We did floor, ceiling. And again, they only asked for 2 examples here, but just for fun, let's recognize, and this is going to be a little bit harder to draw, or to color, I should say. You've got back wall, and if you have back wall, then parallel to back wall will be front wall. Oh my. I'm not getting any awards for coloring today, am I? Okay, so front wall and back wall are also going to be parallel to each other. So look, again, I could name it plane HGC and plane EFB, okay, as long as you name it with 3 points. But on this, because this is a rectangle, a rectangular prism we call it, we'll talk about that a little more later, you're going to have a left and right, a top and bottom, a front and back that are parallel planes. Okay, now they want to know segments that are skew to GH. All right, first things first. Let's find GH. Okay, GH is this line along the ceiling, right? Okay, so if we want skew, remember, non-coplanar. So if I'm at GH, nothing on that back wall is going to work. And in fact, nothing on the ceiling is going to work either because it's coplanar. Right? HG is part of the ceiling. It's a line of the ceiling, and it's a line of the back wall. It's the top of the back wall. It's the edge of the ceiling. Also not going to work is these lines that touch it over here. So on a shape like this, if you're looking for skew lines, the first thing I do is I get to the other side of the shape. So HG is on the back wall. I'm taking me to the front wall. And I don't want the ones that run the same way. I want the ones that run the other way. Okay, so EA and FB are going to be your skew to HG. EA and FB. Okay. All right, now this next one is all for you to try. So the next thing that's going to happen is you're going to see a bunch of questions pop up. You're going to see A, B, C, D, those exact questions, and give them a shot, answer them. In D, it says name 4 segments skew to RQ. There are more than 4 because of the nature of this diagram. I should probably move my floating head. Hold on. There we go. Now you can see the diagram. There are more than 4 segments skew to RQ. So, but as long as you name 4 that are skew to RQ, you'll be good to go. All right. So the next thing you're going to see is 4 questions. Answer them to the best of your ability, please. Please. And then tomorrow, check back because we're going to be talking about the next idea in this topic. Okay, answer these questions to the best you can. The last question is going to be any questions that you have for me. If you have any questions from this video, make sure that you post them and so that I can take a look before we talk again in a couple days. Okay, have a wonderful day and I will see you soon.